All right, well, welcome everyone to another edition of my weather and climate office hours. Thought I'd take a quick moment to reflect on these office hours as they've gone so far. What's funny is that originally these were kind of experimental. I didn't really know how they'd be received, and I certainly didn't expect to be doing them every week. I thought these would be sort of an occasional and as-needed thing episodically. And I think they're still serving that purpose. And I definitely have these less frequently during periods of, I guess we could call, less active weather conditions in California. But I like the value of having the recurring cycle, because it sort of establishes a bit of a routine, and it also allows folks to ask questions in slightly less urgent settings. So I actually do think that having this on a semi-regular basis right now, it's around weekly or nearly so. The schedule does vary from week to week. It's not going to be exactly the same time every week. I will skip some weeks, but then again, other weeks I'll probably have more than one when things are really active or there's something going on that's of particular interest. So I think these are here to stay. The long story short, and I encourage folks to bring other people into the fold so they can answer questions. This is a nice opportunity to really reach a different audience. And to expand a little beyond Twitter. There's always, of course, the Weather West blog, but I do think that perhaps YouTube, well, it's certainly a different format. I'm still getting used to producing my own video content. I'm used to being on camera for other people all the time, but it is still a little bit different. So that's one reason why I've stuck with the live versions of these two. They involve very minimal editing on my part. For the most part, I just edit out the awkward silence for 30 seconds at the beginning and archive it that way. But again, there will occasionally be more produced, edited videos, conversations I have with other folks once I have a bit more time to do so. But for now, these live sessions are going to continue. All right, so let's get into it. In California right now, conditions have once again warmed up a lot relative to the quite cool and still damp conditions as recently as a week or so ago. So there's been a bit of a roller coaster of temperatures and dryness levels this spring. I finally think that the cool, damp weather at lower elevations is probably done for the season. I don't see any indication of it returning in the next couple of weeks, and that's going to get us to June. And it becomes, although not impossible, every 5 or 10 years we do get a wet and cool June, especially in Northern California. It's not very common. So I think that for the most part, that weather is largely behind us, although in the mountains that might not entirely be true. It does still look like it's unsettled up in the high Sierra with occasional showers and thunderstorms for the foreseeable future. So that's a little bit less unusual up at higher elevations in May and June. And that's where it will mostly remain as things transition from cool and unsettled everywhere to quite warm and locally unsettled in the mountains as well. But as those temperatures have warmed, snowmelt is once again accelerating. The big melt is not occurring in just one giant pulse, but it's just in these successively larger pulses through the season. It's still expected that some of the largest volumetric flow rates from the snowmelt pulse are yet to come. They're likely to come in late May or early June, depending on how warm it is. And it does look like we're entering a prolonged period of above or at least near average temperatures. So I don't foresee any more periods of prolonged below average temperatures in the snowmelt regions for the next few weeks. So it's going to be near or above average temperature-wise in those places indefinitely. So that's really going to keep the melt up, particularly because it's this sustained period of above freezing temperatures in most places. So snowmelt is going to accelerate. There's some risk of flooding again later this week in places like the Merced River. Yosemite, parts of Yosemite may have to close again due to disruption to road systems, although again, I don't expect destructive or damaging flooding in Yosemite. It's more just something that they can't really keep the roads open for that many visitors if there's some water on them. But this is not like the gigantic floods we've seen historically in Yosemite. The problem, again, the focus of that snowmelt flood risk remains downstream in the Central Valley, in particular the San Joaquin Valley and the Tulare Lake Basin, where all of this water slows down and accumulates, and there isn't really anywhere else for it to go. So there is a continued flood flight in the Tulare Basin in particular, but also expanding somewhat to other areas as the water continues to rise and fill these basins. And so that's going to be a story that continues to unfold. I don't have a lot of new news other than that it isn't over yet. In fact, the peak is probably yet to come. It's just been slow in coming. So same thing with the Sierra East Side basins in the Owens Valley. There, the flood potential there will continue because there is still a massive amount of snow up there. And in many places in the Southern Sierra, it remains a record amount of snow for the time of year. Of course, the absolute numbers are lower than they were a few weeks ago, but for the time of year, for mid-May, Southern Sierra snowpack remains in many places at record levels. And that's not to say that the snow hasn't melted in some places. In fact, in medium elevations, up to 4,000 or 5,000 feet, a lot of the snow is now gone, especially on sun-exposed areas. There's a bit more remaining on north-facing slopes and in the shade. But below, 5,500 feet, a lot of the snow is gone. But the thing is, most of the snow water equivalent volume is actually above those elevations, where there's still a huge snowpack. So that's the story. If you live in places that saw a fair bit of snow this winter and it's all melted, and you say, well, I guess that's done, keep in mind what's coming from even farther uphill is the main component of what's going to contribute to the flood melt pulse from this point moving forward. Let's see what else is going on. We do have an unusual weather pattern across the western U.S. and western Canada right now, with an extreme, and it really is extreme in statistical and meteorological terms, ridge of blocking high pressure over the interior of western Canada. So we're talking about the eastern portions of British Columbia and much of central and western Alberta. So this is a pattern that is strongly reminiscent, eerily so, actually, and some other meteorologists have reflected similarly to the June 2021 event, which was just such an unbelievably extreme heat wave across a broad region of the Pacific Northwest. Now, there's two things that make this different. The relative anomalousness of the high pressure associated with this system, and even the relative anomalousness of temperatures in some places, is comparable. But the two key differences are, A, this is happening in mid-May rather than late June, so the background temperatures are simply lower. And also, this ridge is centered notably further north. It's a few hundred miles further north. Instead of being centered near the British Columbia-Washington state border, this is centered over more northern parts of western Canada, British Columbia, and the northern parts of British Columbia and Alberta. And so the background temperatures latitudinally are lower, and the northwestern United States is farther away from the center of the ridge. So this event is not bringing temperatures as high as the June 2021 event, even though the relative anomalousness of the high pressure system is actually similar. It is still bringing very hot temperatures to the interior of Alberta and British Columbia and parts of the Pacific Northwest as well, including quite a few monthly records. So yesterday, many places in this area saw their warmest May temperatures on record. Not their warmest May 14th on record, but the warmest temperature on any day in any May in recorded history occurred yesterday across much of the Pacific Northwest, especially as you go north across the Canadian border. That's a remarkable statistic in and of itself, but there may be yet more records today, and there were records the day before that as well. So this is a prolonged heat event up there. And there's also a severe wildfire outbreak ongoing, particularly in the province of Alberta right now, and also parts of interior British Columbia. It's gotten worse with this heat wave, and it may get even worse in the coming days with wind shifts and additional heat, along with the potential for some dry lightning up there. So this sounds a lot like what California experienced in recent years. You'd be correct. The spring is the fire season up there in a lot of places. It's before things get wetter, actually, later in the spring and into the summer in some parts of interior Alberta, for example, and in this awkward window between winter senescence of vegetation and spring greenup. And that spring greenup is being attenuated by the fact that it's been so warm and dry up there as well. So the dynamics are a bit different, but the same factors generally are at play. If it's unusually dry, unusually hot, unusually windy, and if there's dry lightning, none of those things are good from a fire weather perspective, and the forest fires up there are behaving as you would expect under those conditions. There's smoke plumes that are making it all the way to Europe already. Of course, California is usually upwind of Alberta, but that may or may not be the case over the next 7 to 10 days. It's possible that some high-level smoke gets entrained in the anticyclonic circulation over Western Canada, and there could be some higher-level smoke across portions of the western U.S. as well, although I don't think it's going to produce major air quality issues since it's going to be mainly aloft. This won't be like the big smoke transport events of recent years, so I wouldn't worry too much about breathing the air at the surface in places like California, even if you see smoke way up in the atmosphere, which could happen. But just setting the stage, California is warmer than average. It's pretty hot in the valleys right now. Nothing earth-shattering in California because we're quite far from the center of the ridge. Again, it's all the way up in central Alberta, but it's still substantial enough to cause unusually warm conditions in California and induce a little bit of what I'm calling a faux or fake monsoon pattern, a bit of a monsoon imposter pattern, where there is this deep southeasterly or easterly flow across California, so it is transporting some more humid, warm air from the continental interior and the southeast, but it's not really because of the monsoon. The monsoon is because there's a circulation pattern that sets up due to high pressure over the Four Corners region of the United States and due to the seasonal reversal of the wind patterns in northern Mexico. That's not really what's happening with this. This is sort of a northerly forced system, so the winds are coming out of the east and southeast not because of what's happening to the south of California, but actually what's happening to the north of California. So the mechanism is different, but the pattern looks a little bit monsoonal. There's showers and thunderstorms across much of the interior of the west this week, including the Sierra Nevada. Doesn't look like the risk of thunderstorms will extend much outside of the mountains in California this week, but the warm temperatures will. They already have been. And although the warmest days may be behind us, it does look like there'll be a continued period of above average temperatures across most of California for the foreseeable future. So it should stay warm for a while. There's not going to be a quick reversion to cold temperatures like we've seen with some recent heat waves. The exception could be along the immediate coast if the marine layer gets established, but across most of the state it's going to stay warm. Also notable, because we've attenuated some of the strong northwesterly winds off the coast and limited the upwelling, ocean temperatures have become less anomalously cold. In fact, they've warmed by a degree or so off of most of California and along the west coast. So they are still slightly below average, but not much anymore. They're coming up much closer to average because of this decrease in northwesterly flow and the subsequent decrease of coastal upwelling of cold water from beneath. So that pattern may continue for a while as this anomalous high pressure over the interior of the northwest continues this kind of weird southeasterly flow. So ocean temperatures, ironically, may warm in this pattern considerably. And let's see what else. That covers snowmelt, that covers the current pattern, that covers what's going on in BC, which again is quite unusual, record-breaking, but the temperatures are not as warm as they were in June for the regions I mentioned, in June of 2021, excuse me. I think that brings us to El Niño, and really it looks like it's full steam ahead, to be quite honest. All indications are that we are now headed for a strong El Niño event, so confidence has steadily increased. There is now an over 90% chance of El Niño conditions officially being in place come next fall and winter. But more interestingly for California, because again, I'm not so convinced that if it were a weak El Niño that it would tell us very much about California climate, there's now a greater than 50% chance officially of a strong El Niño event, and frankly, based on the dynamical models and observations, I would suggest that it's probably considerably higher than 50% chance of a strong El Niño event in particular. And that matters because the strength greatly affects the impacts. In fact, it's nonlinear. So a weak El Niño doesn't just have weak effects, it has largely non-discernible effects, to be quite honest, on California. But a strong event does have potential for strong impacts on California climate, especially come late summer into next winter. So we're not really there yet. El Niño is not profoundly influencing California climate at this point today, but that may change in 2 or 3 months. So every indication at this point We're not so good at predicting the strength of El Nino necessarily this far out, but there is such unanimity. The very weakest predictions at this point are for a moderate strength El Nino event among the dynamical models, and really the consensus is for strong to very strong El Nino event this year. So this is a conspicuous year, and really it hasn't been that long since the last strong El Nino event. Again, that was in 2015-2016, a year that did not bring remarkably wet conditions to California, but there's every reason to believe that should this strong El Nino event evolve this year, that especially in central and southern California, that the odds of an unusually wet winter this coming winter would be greatly elevated. So we'll see how that plays out. Right now, the seasonal models are reflecting this, predicting a wet condition next winter, but it's really a little bit too early to talk about that part of it. I do think that later this summer there may be some, as I keep mentioning in these conversations, coastally trapped Kelvin waves, which could reduce the upwelling a bit along parts of the California coast and warm ocean surface temperatures, particularly in Southern California and the Southern California Bight. So this is more likely to affect the ocean temperatures from Santa Barbara southward. But during the strong events, we do see coastally trapped Kelvin waves that can affect ocean surface temperatures all the way up through Northern California. So we will see how that evolves. Probably not in the next month or two, but come July or August, and especially into September and October, there's a pretty good chance that will happen. Warmer than average ocean surface temperatures, but it still looks like we could get a good month or two of May gray and June gloom marine layer along the coast. So I don't think it's really going to disrupt the early season marine layer, but it could lead to an early attenuation of that marine layer later in the season. And in terms of whether El Nino brings unusually warm conditions to California this summer before it peaks, not necessarily. Historically, there have been some significant El Nino events, and the summers have even been on the cool side, so I don't necessarily think that's the case. One thing to consider, though, is that we have the global warming trend, which just makes warmer summers more likely irrespective of the state of El Nino or La Nina, so there's that working in the background. I'm not sure El Nino necessarily raises the likelihood of an especially hot summer in California, although it does raise the likelihood of hot summers in many places globally, but I do think it raises the odds that this coming autumn and would be warmer than average, because that's when we tend to get more autumn heat waves, and we have a much warmer coastal ocean in autumn than usual during strong El Nino events in a lot of cases. So I do think it means that the autumn is probably going to be warmer, maybe more humid than usual, so we'll see how that goes. Doesn't mean we can't see dry offshore wind events as we often do in autumn, but it just means on average that's more likely to happen. Globally, this is going to be a very significant El Nino event because it's likely going to bring record global temperatures. The global ocean surface temperatures remain at all-time records in the observational era by a considerable margin. They've been that way for weeks now. So the oceans are already record warm. That is probably going to translate over to the atmosphere later this year. And in some places, there are going to be record-breaking heat waves. There is right now in the interior of British Columbia and Alberta. There have been in the last few weeks across portions of southern and western Europe. Southeast Asia, a bunch of countries actually just saw their hottest temperatures ever on record in the past couple of weeks. In a lot of places, the spring, in warm tropical occasions, the spring can actually be spring such as it is in the tropics where there's decreased seasonality can be the hottest time of year because it's a time of year when you have the strongest sunshine combined with the least amount of rainfall. By the time you get to the middle of summer, you tend to get pretty frequent tropical thunderstorms in some of these places, which cools things down a little bit. So it's not surprising that the hottest temperatures of the season are occurring in spring, but what is remarkable is that relative to the historical record in some of these places, we are seeing temperatures that are higher than we've seen in over a century of record keeping in a lot of these places. So the heat is out there. It's warm in California, but not exceptional. But this El Nino event superimposed on the global warming trend is likely to bring about record-breaking global temperatures either later this year or even more likely early in 2024. So it's going to be a long period of potentially very active global weather extremes. We're going to see a lot of record-breaking heat and perhaps some record-breaking precipitation events as well. And again, California is just one region globally, and California does not necessarily see some of its highest extreme temperatures during El Niño events, but it can see definitely during winter, especially during strong events, a signal towards heavier rainfall events. So we'll just have to see how that evolves. This does not mean it's going to be a record hot year in California necessarily, but I do expect it to be record hot in many parts of the world and probably on a global average basis by the end of the year. So this is a big deal from a global climate perspective, especially in the context of climate change. So I think that's my monologue for the day. I'm going to start looking through questions, answering them as they come through. So I know there's some folks who wait until this moment to write them, so this would be a good time to start adding them to the chat. I'm going to scroll back to the beginning and see what we've got so far. There was a question from Ishmael about whether we should expect higher summer temperatures in the Central Valley this year. That is, I think I partially addressed that already, but not always. But there's not just, El Niño is not the only factor at play, and we do have the long-term warming trend, and the Central Valley has been getting hotter in summer, faster than a lot of the rest of the state. So it's not to say we shouldn't expect very hot temperatures this summer. It's just to say that they aren't necessarily occurring because of El Niño, but they could very well happen anyway. And I do think that the likelihood of things being warmer or hotter than average in the autumn probably will go up because of El Niño this year. So it's a little bit less of a summer thing and more of an autumn thing in that respect for California. There's a question about fire season. I may return to that in a moment after I see what else is coming through. Let's see here. Some folks commenting that they're joining from other locations: Thunder Bay, Canada, Bozeman, Montana. That's great. Today, actually, I'm talking more about those places than I usually would, so that's very convenient. But great to see folks from other places as well. There's a question from Ed about Lake Mead. So I'm just making a mental list of what to go through. So I'll touch on fire season. I'll touch on the progress of water in the Colorado River Basin and the big reservoirs. Let's see. A comment from Fog Machine that the nearshore ocean surface temperatures are now above average off the Washington and British Columbia coast. That's not too surprising given the surface weather conditions they've had in the past week or so. All right, another question about the Colorado River and Lake Mead. Summer rain in El Niño, I can talk about that too. Related question to that. And fall wind events. Okay, I got a mental list for now. 3 things. Starting with fire season. I've mentioned this before, but I think it's worth re-emphasizing as we get closer into the heart of fire season. To be clear, we're not there yet. California almost always has a late peaked fire season. Peaks mid to late summer in the mountains, and then often late summer into autumn at lower elevations. So we got months to go in some places. And this year, it might even be a little bit delayed relative to usual. I think everyone's running at least a couple of weeks and maybe a month or so behind. Locally more, locally less, but generally everyone's running a little bit behind. So fire conditions in a lot of places are more like typical April conditions right now. So it is to say the likelihood of severe large fires right now is low for the most part because things are still relatively moist. Yes, you can get grass fires, you can get brush fires when it's dry enough to have those fires, but they're generally not going to be high intensity, fast moving fires given the vegetation and weather conditions we're seeing right now. So it's unlikely that there'd be fires that are very dangerous or destructive at this point in time anywhere. It's almost impossible to have really fires at all right now at very high elevations because there's still a heavy snowpack on the ground. So I know there's some crews that are getting some good work done on prescribed burns and burn piles up at higher elevations because some of those burn piles are still in between giant snowdrifts. So it can be a good time to do some of that right now. But later in the season, I know, is what the main question is here. And here's my prediction. This year, it's likely that the high elevation fire season in California, and really across a lot of the interior west, actually above 7, 8, 9,000 feet, will be greatly attenuated. In some places will be minimal fire activity at high elevations. And that's mainly because of the large snowpacks that accumulated this winter and spring and are to a large extent still there. So even when that snowpack mostly melts by the end of summer in these places, the soil moisture is still going to be higher than in a typical year, which will help the plants have higher moisture levels, and so fire risk will be, I think, greatly attenuated at high elevation. So that's great. I don't think there's going to be any Sierra Crest or Continental Divide crossing fires like we've seen in recent years this summer. So that's nice. Middle to lower elevations, it's a bit of a different story. In California on the west, we have two macro fire regimes. The climate limited ones, or sometimes you call them moisture limited. So these are places like forests where there's always plenty of vegetation to potentially burn. There's always fuel for the fire, so to speak, but it's a question of how dry that fuel is. And in hot, dry conditions, you get much bigger, more severe fires in those places. Under cool, damp conditions, you get minimal or low fire activity in those places. So that's why it's called climate or moisture limited. In those places, this year might be a less severe fire season, or delayed, at least at the beginning of it. At other places, though, which are more fuel limited fire regimes, these are like grasslands and chaparral and oak woodland and places where there's mixes of grass and brush and trees, essentially. These are places where conditions are less dominated by how dry things are and how much vegetation there is. And in fact, it's the wet years when there's often more vegetation in these places. There's more grass growth, there's denser brush growth, and you can actually get increased fire activity in the wet years once things do eventually dry out. So I still think even in these places, we may be a bit delayed this year due to weather conditions. So I still think we may see a late start to the fire season, significant fire season anyway, at lower elevations as well. But I think that the peak of fire season could well be fairly intense at lower elevations. So in these vegetation limited regimes, in the grasslands, the brushy areas, and in these sort of mixed woodland, brush and tree type environments in different parts of the state, because there's a lot of extra grass and brush that have grown this year, and it will inevitably dry out by the end of the season. And so then the question becomes, do we get big heat waves and wind events or dry lightning events at the end of the season, August, September, October? If that happens, it could be a very active fire season at places where most people live, in the coastal parts of California and in the lower foothills. I think it's unlikely to be a very active fire season at high elevations no matter what happens meteorologically. I guess never say never, but there's a pretty strong signal that it will not be a severe fire season at high elevations. But that's not true at lower elevations. In fact, it could very well be the opposite. We could see an active fire year if things dry out and get windy August onward. But I don't think we'll get there probably until at least late July. So there's at least another month or so of probably pretty relatively quiet fire conditions. Could there be exceptions? Could there be an extreme wind event or heat wave event that changes the situation? Yes, there could be. But again, these are broad scale predictions. Regionally, I think, as I mentioned, across much of the western U.S., the interior Rockies especially, fire season will be attenuated at higher elevations and in forests because of that big snowpack, but accelerated at lower elevations. So the rangeland and the grassland fires and the meadow fires in between the forests could be worse than usual this year because there's a lot of extra growth. You might also see some significant fire activity in the high deserts this year because that sagebrush and the invasive grasses, unfortunately, in between patches of sparse vegetation, they're sort of filling in the gaps in years like this and providing continuous fuel beds. So there may well be larger and more active grassland and rangeland and desert fire activity in a lot of parts of the interior west this winter. So this could be a big Great Basin fire year because there, again, it always gets hot and dry in summer. The question is there enough vegetation? And this year there's a lot of extra growth. Things are a bit different in the Pacific Northwest. Fire season is starting early up there. They've been hotter and drier than usual recently up there, and that's probably going to lead to an earlier fire season unless there's an unexpected bout of significant summer rainfall, which can happen up there. But right now, the Pacific Northwest interior is on track for an earlier and more severe than usual fire season. even more so in Western Canada, where of course we're seeing very large and destructive fires, high-intensity fires right now that are causing mass evacuations, burning towns, and again, these are not low-intensity understory fires in the forest. These are definitely stand-consuming fires that are ecologically probably causing more harm than good right now in a lot of places up in Alberta due to the weather conditions and the drought. So a pretty varied set of conditions, and there's a bit of a dipole where things are more active with a higher potential for a bad fire season up north this year than in California. And that dipole often exists, where often when it's really wet in the southwest in California, it's often not so wet up in the Pacific Northwest and Western Canada. So we're seeing that dipole in spades this year. All right, hopefully that covers fire season. Then it comes to whether or not El Niño might favor slightly increased risk of summer precipitation or thunderstorms in the autumn. And I think the answer is yes. I don't think it's a huge shift in California, but you know, the background likelihood's low, so I suppose it's notable in that context. That's mainly because it slightly increases. It may not affect the monsoon directly so much, but it does probably at least modestly increase the likelihood of tropical cyclone remnant events beginning in August and through about October or so, where the either moisture or the remnant circulation from East Pacific hurricanes or tropical storms tend to get entrained into flow that makes it over California. These can result in a very wide range of other conditions that we've experienced in recent years. We've gotten lucky in Southern California. These have been fairly wet events in recent years. Last year it helped us defuse what could have been a much more severe fire season because it brought a lot of widespread rain to Southern California rather than a major wind and lightning event without the rain. So that actually helped fire season. But we've also seen that in previous iterations, it's brought widespread dry lightning events. So you can get the mid-level moisture without the low-level moisture. You get the instability, and under the right conditions, you can get big dry lightning outbreaks as a result of these recurving East Pacific tropical storms. And if they happen in August through October, that is the driest window where the vegetation is driest, so you tend to get a lot of wildfire ignition. So that could be not so good. So it does increase the likelihood of either of these things. The net, what it does to fire season is I don't know, because it can increase both the likelihood of fire season ending rainfall, but also of dry lightning events in late summer and early autumn. And again, not by a huge amount, but by probably a modest amount, especially if it's a strong El Niño event. There probably would be some increased likelihood as the sea surface temperatures off the coast of Baja California and in the California Bight warm to above average levels. I'm noticing a little bit of instability in my internet connection, so hopefully it's not too bad for folks. But just slowing down to let that catch up. I will have hopefully a new office set up in the next few weeks, by the way, and it might help decrease some of these issues. I know there's background noise from my computer. That's just an unavoidable fan hard drive issue due to proximity. I think I'll be able to figure out how to set that up a little bit better. You may notice a different background. So that covers the El Niño summer rainfall component, and I've spoken for so long I've already forgotten a little bit about what the third thing was. Oh yes, Western Water, Lake Mead, Colorado River. This has been a good year for the Colorado Basin in general. Nobody really knows exactly how much water is going to end up in the big reservoirs because there's the legacy of this climate change amplified severe drought conditions for years. So one really wet year, of course, doesn't completely erase it, but it does help, and there will be good inflows, I think. The question is whether they're moderately good or very good, I think. So the range of outcomes. This will not be a poor runoff year. That's the good news. This will be good for the Great Salt Lake, which is at risk of drying up, essentially. Again, won't solve the long-term problem, but it will help, certainly, this year. The big reservoirs, Lake Mead, Lake Powell, they'll get nice inflows this year. I have no idea how much they're going to rise. No one really knows, but they will probably rise significantly, at least for the next month, with snowmelt. It would be great if we got a good monsoon season to follow up. That's no indication that we will, though. In fact, if anything, the odds are slightly favoring a slightly below average monsoon this year, but again, monsoon seasonal predictions are not good, so I wouldn't put too much stock in that. But the best case scenario would be a really good monsoon to follow the good snowpack. If we get another not so great monsoon this year, following a good snowpack, then the benefits will be somewhat attenuated, but of course it'll still be better than not having that good snowpack year in the first place. So Overall, it's a fairly good news water year for the Colorado Basin, but it does not solve the long-term problem, and there is concern that a decent year sort of staving off disaster might actually make it harder to address the problem in the long term, because things were looking so bad going into last winter that essentially we were reaching the crisis point and decisions were going to have to be made. It is very possible that now, when the immediacy of that crisis is pushed off by 12 to 18 months, that folks might say, okay, great, well, the problem is solved. When it's really not solved, it's just we got a bit of a temporary reprieve, but I think it's critically important to view that as a temporary being the operative word there. This is not going to obviate the need to solve these problems with water security and water use in the long run, especially in the Colorado Basin, even though, I'm glad it happened this year of all years, because it does give us some breathing room. Hopefully that's how we use it, rather than use it as an opportunity to just continue to ignore the long-term challenges with water on the Colorado Basin. A bit of editorializing there, but I think that that's appropriate in this context. All right, let's see if anything else came in. I think I've covered most of what folks have. There's a comment from Brody at the end there that the negative PDO, the Pacific Decadal Oscillation, is fading rapidly. It does look like it's fading. We'll see if it stays faded. It is worth noting, though, that if it doesn't completely go away, that it could affect, to some extent, the El Niño teleconnections this winter. So if El Niño is strong enough, I think it'll still win out over a lot of other influences, but it could be a bit of it could modify the placement of high and low pressure anomalies if the northern Pacific stays in a negative PDO-like configuration with an arc of colder waters along the coast and very warm waters at the central North Pacific, as well as in the tropics, of course, associated with El Niño. We'll just have to see what happens. But right now, around the world, in the North Atlantic, for example, we have a completely historically unprecedented combination of potential for strong El Niño conditions and very warm North Atlantic ocean temperatures in the main development region for Atlantic hurricanes. That essentially hasn't happened before. So if it happens, we are literally in uncharted territory. Usually, a strong El Niño would suppress the Atlantic hurricane season because of increased wind shear, which is unfavorable for the vertical stacking needed for tropical cyclone vortices to align themselves correctly and strengthen. But if the ocean temperatures are ridiculously warm, even if the shear is increased, then there might be fewer opportunities because of the shear, but the high-end potential for the storms that do develop is actually higher than usual. So we could see an unusual combination of competing influences between an El Niño suppressive effect on hurricanes in the Atlantic and a hurricane accelerating effect of extremely warm or even record warm ocean temperatures there. So the same thing can play out in the Pacific. It may not be record warm temperatures locally near the California coast, but anomalous or even unprecedented combinations of temperature patterns in the Pacific could complicate things this year. So that part is less certain. We're just going to have to see how it evolves in the coming months. But we'll just have to see how it goes. It's going to be an interesting year. This looks like a really big El Niño event. This is not one of those years where the media is overhyping El Niño, like a weak El Niño, to mean more than it is. This looks like it has a high potential of being the real deal and is going to have large global effects and will probably bring about record-breaking global temperatures by later this year or early next year, and also is very possibly contributing to some of the record-breaking heat waves and precipitation events we're seeing all around the world right now, and we'll probably continue to see in different places this summer, because again, this releases a lot of latent stored energy into the atmosphere. And we've had a lot of that stored beneath the surface of the ocean during a persistent La Niña event in a global warming era. So it's going to be an interesting year. That's my very succinct informal prediction. All right. Well, with that, I think I'm going to call it an hour at the 40-minute mark today, since I'm doing these regularly. So I think I'm able to capture questions more comprehensively as I do them frequently. So. Feel free to join again next week. I'll plan to have one probably at a similar time, although just stay tuned for the specific announcement there. Thanks as always for joining, and I'll see you next time.